Hey guys, it's Miss Udo, and for the next 8 weeks, I will be teaching your math class. And so we are going to be using Nearpods with questions embedded for our math lessons. And so we're going to go ahead and begin. So today's lesson is on the distributive property. And as a matter of fact, all this week we will be learning about different properties of multiplication. So let's begin. Before we start our class, I want to make sure that everyone has all of the supplies that they need for today. So if you don't already have your math journal and a pencil, please take a second to go and grab those items. You are going to need your math journal and a pencil every single day. Now, if for some reason you don't have a math journal, please make sure that you can grab a sheet of paper that you can write on and a writing utensil. You're going to want to make sure that you keep all of the pieces of paper that you take notes on during math class in a safe place so that you're able to locate them when you need to refer back to your notes. You're also going to want to make sure that you have your Google Classroom tab open just in case we have to go back there to look at some items or assignments. And we're always going to start class with an open mind and a positive attitude. So the next thing that I want to talk about is our math norms. Our math norms are the things that we are going to refer to every single class period. And so there are 5 standard math norms. The first math norm is that errors are gifts that promote discussion. This means that even when we don't get the correct answer, it is absolutely okay. And the reason it's okay is because when we make mistakes, it gives us something to talk about that will help us to get better at our math. Our next math norm is to ask questions until ideas make sense. You guys are going to find that during these lessons, I'm going to ask you a lot of questions that are going to require your response on the Nearpod. And so make sure that you're answering those questions because as you do, they will make the ideas make more sense to you. The next norm is to talk about each other's thinking. Now, this one's a little bit difficult because we're learning virtually. However, with our questions that we ask through our Nearpod, as well as the breakout sessions that you guys are going to have with Miss Holland once a week, that will give you an opportunity to talk more about your thinking to others. Our fourth math norm is answers are important, but they are not the math. You are going to notice that many times we are literally going to spend a nice amount of time on the problem and it won't even be about getting the correct answer. It is literally going to be more about working through and thinking through than it is about getting an answer. And then number 5, use multiple strategies and multiple representations. We are going to solve so many problems and we're going to solve them in so many ways. And there is no one correct way to answer a problem. It is always best that we learn multiple strategies and we determine which strategy works best for us when we're looking to solve our problems. Now, in the corner of our slide, you're going to see that there is a pencil. And the reason there's a pencil in the corner of our slide is because you need to make sure you have one handy. As we're learning, you're going to see that sometimes there will be a pencil on your screen. If you see a pencil on your screen, that means that it is something that you might want to write down. All right, guys, so we are going to begin with our warm up. Now, our warm up questions are questions that sometimes can be solved mentally, but other times you may want to write them down in your notebook. We aren't going to go back and check them, but you are going to have to answer them in your Nearpod. So let's begin with our first warm up question for today. It says, Louise wrote the multiplication pattern below. 9 times 3 equals 27. 4 times 9 equals 36. I'm sorry, I said the other one backwards. 5 times 9 equals 45. And 6 times 9 equals blank. What is the missing number in her multiplication pattern? Again, 3 times 9 equals 27. 4 times 9 equals 36. 5 times 9 equals 45. And 6 times 9 equals blank. What is the missing number in Louise's multiplication pattern? The question should be appearing on your screen right now. All right, guys. Well, let's check our solution. We have Louise's pattern. 3 times 9 is 27. 4 times 9 is 36. 5 times 9 is 45. And 6 times 9 is what? Well, there are several strategies that we could use to solve this problem. One strategy that we could use would be to make an array. And so I'm just going to draw an array on my screen. And my array is going to have 9 boxes going across. All right, here is my array. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we had our first set of boxes from our problem. We started with 9 times 3. So that meant that there were 3 rows of 9. And then the second 9 times 4, which was 36, gave us another row of 9. And so I'm actually going to go back here and write numbers. So here was 9. They didn't tell us about 9 times 2, but I know that 9 times 2 equals 18, so I'm going to write that here. I know here from this row that 9 times 3 is 27. 9 times 4 is 36. The problem tells me that 5 times 9 is equal to 45. And here is my last row with 6 times 9. And so one strategy that I could use in order to figure out what 6 times 9 is using my pattern would be to count on from 45. 46, 47, 48, 49, 50, 51, 52, 53, 54. 6 times 9 is 54. 54 is the number that is missing from my pattern. Now, there are several other ways that you could have solved this problem. In any way that you solved it, if you were able to get 54 as your answer, was a correct solution. Great job, guys. Let's take a look at question number 2. Lydia has 7 pairs of gloves. Which equation could Lydia use to find out how many gloves she has? I'm going to read it one more time. Lydia has 7 pairs of gloves. Which equation could Lydia use to find out how many gloves she has? And our choices are 7 times 3 equals 21. 7 plus 2 equals 9. 7 times 2 equals 14. Or 7 times 7 equals 49. The question should be on your screen to solve now. All right. Well, let's take a look at our answer. Lydia has 7 pairs of gloves. There is a word that is very important in this problem. And if you don't know what it means, it's going to be really hard to solve it. And that word that I'm referring to is pairs. Lydia has 7 pairs of gloves. Well, if you don't know what pairs are, I know you know what gloves are. Gloves are the things that we wear on our hands when we're cold. And right now it's about to get really cold. And so if you are trying to figure out what a pair of gloves are, maybe you can start by thinking how many gloves you need to cover your hands. That's right. If you're going to put gloves on your hands, you would need 2 of them because you have 2 hands. So a pair means 2. All right, so let's take a look at our question again. Our question tells us that Lydia has how many pairs of gloves? Our question tells us that Lydia has 7 pairs of gloves. Well, if Lydia has 7 pairs of gloves, and we want to find the equation that will tell us how many total gloves Lydia has, what would it be? Did you say 7 times 2? If you did, you are absolutely correct. And we know this is correct because our first pair would be our right glove and our left glove. So we've got 2 gloves here. And we would have a second, third, fourth, fifth, sixth, and seventh. And if I look at the array that I've just created, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 total gloves. So the correct answer for this problem is C. 7 times 2 equals 14. How did we do, guys? All right, time to get into that lesson. Our objectives for today are I can break apart unknown facts into known facts to solve multiplication problems. Also, I can be precise in my work. Our key term for today is distributive property. The distributive property tells us that multiplication facts can be broken apart into the sum of 2 or more other multiplication facts. Ooh, that word sum. That's a word that we should all be very familiar with. The sum is what we get when we add 2 numbers together. Let's take a look at our anchor chart for today. Again, the distributive property is all about breaking things apart and putting them back together. I want you guys to take a quick look at the different pictures on my anchor chart. There is now a question for you on your Nearpod, and that question is, what do you notice about the number of counters in each set? And so there's several pictures here, but what do you notice about the number of counters in each set? Did you say that you noticed that each set has the same number of counters? Let's take a look. In our first picture, I have, and I'm looking at this one in this top corner. In this first picture, I have 3 times 5 is 15. So there's 15 counters here. And then I have a 3 by 3, which is 9. And there's a total of 24 counters. In this picture here, I have 3 times 2, which is 6. I have another 3 by 2, which is 6. another 3 by 2, which is 6, another 3 by 2, which is 6, and I have 24 counters. Moving on to my center picture, I have 3 by 4, which is 12. I have a 3 by 4, which is 12. And that also adds up to 24 counters. And in my top corner here, I have a 2 by 8, which is 16, a 1 by 8, which is 8, and it adds up to 24 counters. The distributive property teaches us that no matter how we break apart our array, when we put it back together, the number of counters that we have will remain the same. So as we're learning together, guys, we are going to learn through problem solving. And the reason we're going to learn through problem solving is because problem solving is something that many of us struggle with during our lessons and during our assessments. So every day, I'll be presenting a different problem to you, and we are going to work through solving it together. As we go through the lesson, there'll be times where I'll pause and have you answer a question on your Nearpod to make sure you're keeping up. So let's go ahead and get into today's anchor problem. It says, Maria wants to set up 7 rows of 4 chairs for a meeting. She wants to know how many chairs she needs, but she does not know the product of 7 times 4. My Bitmoji's in the corner, and my Bitmoji is reminding us of what we learned about the definition of the distributive property. And that is that we can use the products of known facts to help us find the products of unknown facts. So we can take multiplication problems that we know and use them to help us figure out those that we don't. And by doing that, today we are going to help Maria find out how many chairs she needs. All right, guys. So let's take a look at our problem. We know that Maria has 7 rows of 4 chairs for her meeting. Maria has decided that she is going to separate her chairs into 2 groups based on the model that you see here. And so while Maria thought this was way too many chairs to look at once, she decided that she was going to look at this set of chairs, and then she was going to look at this set of chairs. So we have 2 different sets of chairs now. And the question is, can you help Maria figure out how many chairs she needs now that she's broken her chairs into these 2 different groups? Well, let's see. If I look at my first group, it appears that it's created a smaller array. And in this smaller array, I now have 1, 2, 3, 4, 5 chairs going down, and 1, 2, 3, 4 chairs going across. So I have 5 rows and 4 columns. That tells me that my multiplication problem here is 5 times 4. Well, even though we may not know what 7 times 4 is, many of us know what 5 times 4 is because we know how to count by 5s. Tell me, please, using your Nearpod, what 5 times 4 is. Did you say 20? That's right. 5 times 4 is 20. And I know that because when I count by fives, 5, 10, 15, 20. So I use skip counting as my strategy this time. Now, if you are not fluent with counting by fives just yet, that's absolutely okay. You could have solved the problem by counting the chairs in our first array. So we know that the blue set of chairs has 20 total chairs in it. Well, let's look at the yellow set. When we look at the yellow set of chairs, there are 1, 2 chairs going down, and 1, 2, 3, 4 chairs going across. Because we have 2 rows and 4 columns, this array can be represented using the multiplication expression 2 times 4. Use your Nearpod to tell me what the product of 2 times 4 is. Did you say that the product of 2 times 4 is 8? If you did, you're absolutely correct. You could have skip counted by 2s, 2, 4, 6, 8, or you could have counted all the chairs to find out how many chairs were in this array. So far, we know that Maria's first set has 20 chairs and her second set has 8 chairs. I wonder what we're going to do next. Here's a hint. It has something to do with that word sum. So let's take a look. We found out that the top row had 20 chairs and the bottom set had 8. I reminded you that in our key terms for distributive property, we said that we could take our array apart and then put it back together by finding the sum. What operation do you think that we're going to use if we are finding the sum? Write your response on the Nearpod. I hope you said that we're going to use addition. If we are finding the sum, it means that we are going to add. And so, what 2 numbers are we going to add together? That's right. We're going to add the 20 and the 8. Use your Nearpod to tell me, what is 20 plus 8? 20 plus 8 equals 28. Great job, guys. And so when we added our 20 plus 8, we got 28. And Maria wanted to know how many chairs she needed. And she originally had 7 rows of 4 chairs with a multiplication expression of 7 times 4. And so now I think that we all know what 7 times 4 is. Can you tell me what 7 times 4 is? Respond on your Nearpod. That's right, guys. 7 times 4 equals 28. You guys are absolutely amazing. All right, now it's your turn. I am going to ask you guys a series of questions and you are going to respond in your Nearpod. And then we'll go through the answer at the very end. So, our problem has remained the same. Maria is still setting up chairs 7x4. But this time, Maria's brother, Jose, solved the problem too. But his model looked just a little bit different than the one that we used. His model is right here on the side. And as you can see, there's a blue set. And then there is also a purple set of chairs. And so the first question for you to write the answer to in your Nearpod is, what multiplication equation is modeled by the array in the blue box? So in the blue box, this box right here, what multiplication equation is being modeled? What multiplication equation is modeled here? I hope that you said that the multiplication equation modeled in the blue box is 1, 2, 3, 4, 5, 6, 7 by 2. 7 by 2. My next question is, what multiplication equation is modeled by the array in the purple box? What multiplication equation is modeled by the array in the purple box? Did you say that it's also 7 times 2? If you did, you're absolutely correct. Interesting. Looks like they are the same. What product is modeled in the blue box? Remember, the product is your answer to your multiplication. What product is modeled in the blue box? Did you say 14? If you did, you're absolutely correct. 7 times 2 is 14. And you could have used skip counting, or you could have counted the chairs. Well, that makes the next question very easy, guys. What product is modeled in the purple box? That's right. In the purple box, we also have 7 times 2, so it's also 14. Question number 5. What operation will I use to find the sum of both arrays? What operation will I use to find the sum of both arrays? I hope you said addition. And so now tell me, what is the sum? What is the sum? We have two arrays. What is the sum? That's right. 14 plus 14 equals 28. And my final question for you is, did Maria and Jose get the same answer? Yes, they did. Maria and Jose both got 28. Great job, guys. All right. Well, let's review what we learned today. The distributive property tells us that we can break an unknown multiplication problem into two or more smaller problems, and then we can put them back together. And so when Maria solved her problem, Maria broke apart her arrays into a 5x4 and then a 2x4. She added them together and 5 times 4 is 20. 2 times 4 is 8, and so her total was 28. Jose also broke his array apart, but this time he broke his into a 7 by 2 and another 7 by 2. When he added them up, he got 28, which was the same answer. You all did a fabulous job today. For the remainder of class, you are going to go to Dreambox. There is an assignment using distributive property in your Dreambox account. You are to work on this assignment until the end of class. Great job, guys. See you tomorrow.